Okay, let's just dive right into this. Welcome to The Explainer. Today, we are unpacking what has to be one of the absolute greatest cosmic mysteries, and it's sitting right next door in our own solar neighborhood. We're talking about Venus. But more specifically, we're going to look at an incredibly ambitious upcoming mission that's designed to figure out exactly what went so horribly wrong with Earth's so-called evil twin. Earth and Venus are basically considered twins. They're almost identical in size, their mass, their density, and they actually formed from the exact same solar nebula. But here's the catch. While Earth became this lush, habitable haven with vast oceans and thriving life, Venus took a fundamentally catastrophic path. Today, it is literally a hellscape. It's actually the hottest planet in our entire solar system. Yeah, even hotter than Mercury. We're talking surface temperatures around 460 degrees Celsius, all sitting under skies choked with highly corrosive sulfuric acid clouds. It is a runaway greenhouse effect gone completely mad. To truly wrap your head around just how hostile Venus is, think about the number 90. The atmospheric pressure standing on the surface is 90 times greater than what we experience every day here on Earth. To put that into perspective, standing there would feel like being crushed 900 meters deep inside Earth's ocean. No wonder the few Soviet probes that actually managed to land there back in the 1980s were completely destroyed in like 2 hours. So, how on earth do we study a planet that just destroys everything it touches? Well, we do it from orbit. Part 1. Enter Shukrayaan-1, India's Venus Orbiter mission. So this is the Venus Orbiter mission and is officially named Shukrayaan-1. It's the Indian Space Research Organization's highly anticipated first ever mission to Venus. And the timeline here is super aggressive. ISRO's targeting a launch date of March 29, 2028. The spacecraft is going to lift off aboard the massive LVM-3 rocket from the Satish Dhawan Space Center over in Sriharkota. From there, it's basically a 112-day sprint through deep space before it fires its engines in July 2028 to perfectly execute its Venus orbit insertion. And once it arrives, Shukrayaan-1 is packing a massive arsenal. We are talking 19 different scientific payloads weighing roughly 100 kilograms in total. Now, to get all of these heavy instruments into the absolute perfect viewing position without just, burning through tons and tons of fuel, it's going to use this genius maneuver called aerobraking. Basically, the spacecraft will repeatedly dip into the upper layers of Venus's thick atmosphere. It uses the atmospheric drag as a natural brake to gently settle into its target polar science orbit, which sits roughly 200 by 600 kilometers right above the surface. Part 2. Seeing through the clouds. Okay, but studying Venus from space presents an absolute engineering nightmare. How do you see the surface when the entire planet is permanently shrouded in an impenetrable blanket of thick haze? Well, enter the VSAR, or the Venus S-band synthetic aperture radar. This is the flagship instrument of the whole mission. Operating at a 2.5 gigahertz frequency, its radar waves will literally punch right through the darkness and the clouds to map the surface, day or night. It's specifically hunting for active volcanoes to prove once and for all if Venus is still geologically alive. But here's the best part. Shukrayaan-1 isn't just stopping at the surface. Oh no, it's going deeper. It's also going to deploy VERITAS, which is a low-frequency ground-penetrating radar. Listen to this. No spacecraft in history has ever studied what lies beneath the surface of Venus. None, making VERITAS a true first of its kind. It's designed to penetrate several meters below the crust to reveal hidden rock layers, ancient lava flows, and the whole geological history buried deep underground. It's like an X-ray for the planet. Part 3. The Hunt for Life. Now, while the radar maps the rock and magma down below, other instruments are going to look up to the sky for an entirely different, totally mind-blowing question. Could there actually be life here? I know, it sounds crazy, but to answer that, we have to talk about a chemical called phosphine. On Earth, this toxic gas is overwhelmingly produced by biological organisms, specifically anaerobic bacteria, which is just life that doesn't need oxygen. Because it's so tightly linked to biology, scientists consider it a biosignature. And in 2020, researchers completely shocked the world when they detected traces of phosphine high up in the Venusian clouds.
Right, so while the surface of Venus is hot enough to literally melt lead, if you go up about 50 kilometers into the atmosphere, things change. The temperature drops to a balmy 60 degrees Celsius, and the pressures are shockingly similar to Earth's surface. It's surprisingly Earth-like up there. Shukrayaan-1 will carry specific payloads custom designed to analyze this exact atmospheric chemistry. It's going to hunt directly for that elusive phosphine to either confirm or totally rule out the incredible possibility of microbial life floating around in the clouds.
Part 4. A global space mission.
Trying to answer questions this massive, well, it takes a village. While Shukrayaan-1 is an Indian-led ISRO mission, make no mistake, this is a massive global collaborative effort. For instance, the viral instrument, which is jointly developed by Russia and France, will be the one hunting for that phosphine gas we just talked about. Meanwhile, Sweden is partnering up on VISWASC to study how solar winds interact with the planet. And Germany? They are collaborating on the Ravi instrument to study the radioanatomy of the ionosphere. It is a truly international scientific alliance coming together for this.
Which ultimately leaves us with this final, incredibly provocative thought. Venus and Earth started out with the exact same raw materials, the exact same starting line. Yet Venus became a toxic, boiling wasteland. Shukrayaan-1 isn't just about exploring some distant planet. It's fundamentally about understanding the extreme limits of our own planetary climate. By investigating the death of Earth's twin, are we actually learning the crucial lessons needed to prevent the exact same fate for our own planet? Well, we are going to start finding out in 2028. Thanks for joining me for this explainer, and I'll catch you next time.